Science in Pajamas. Alright, so today we're going to talk about the Bohr's model. What it is, it's a way to kind of diagram the atomic structure of different atoms. Now, here's the thing about Bohr's model. It was created by a guy named Niels Bohr, and for a while it was considered to be the best model for the orbitals of an atom. However, we've since learned that the orbitals actually move in different ways. So the rings around the Bohr's model aren't actually the orbitals anymore. However, a Bohr's model is still a great way to show the energy levels of the different electrons. So that's what we are going to look at today. And I'm going to show you the easy way to do it that I wish I learned in chemistry, because I struggled with these so much because no one actually showed me how to do them. So I'm going to show you the easy way to do it using the periodic table. Now, the periodic table is set up the way that it is for a number of different reasons. And it all boils down to that weird shape of it. You know, like how it goes up and down and all that, and these are down there. Well, these are mostly down here because if you were to put them right there where they belong, it'd be too long to fit in a book. But this whole weird shape of it is actually for a reason. It's because we can look at this and figure out patterns in properties. But it also lets us figure out how to do the Bohr's model. All right. So what the Bohr's model is you have the nucleus in the middle, and then you have rings around it, kind of like how the planets orbit the sun, with the sun in the middle. And you have a certain number of electrons in each ring. Like I said, I figured this out at one point when I was teaching it, and I was so mad that no one ever showed me this trick. So we are going to start with an easy one. We are going to start with aluminum. Has an atomic number of 13, so that tells us it has 13 protons. So I'm going to start with my nucleus. So 13p. I want to figure out the average number of neutrons. The atomic mass for aluminum is 26.98. We can round that to 27. 27 minus 13 would be 14 neutrons. All right. Now let's do our electrons. This is the part that always got confusing for me, because again, I wasn't ever told how to do it. Now, aluminum is in the third row. So row 1, row 2, row 3. That means it's going to have 3 rings. 1, 2, 3. And next we have to figure out, okay, how many electrons go in each ring? Well, I have the number of electrons that can fit in each energy level memorized, but that's just because I've done this so many times at this point. Remember how we said that since it's in row 3, it means that there are 3 rings? Well, the number of actual elements in each row tells us how many electrons that energy level can have. So first row, which corresponds to ring 1, has hydrogen and helium. 2 elements, so 2 electrons can fit in that first row. The next row, row 2, or which corresponds to ring 2, has 1, 2, 3, 4, 5, 6, 7, 8. It can hold up to 8 electrons. And the last row, and we're not going to go all the way across. We are going to count, but we are going to stop when we get to aluminum. So aluminum is right here. So we have 1, 2, 3. There are only 3 electrons in the outermost energy level for aluminum. So this is aluminum. See, not too bad. Now we can also do this with a really, really big one. Ready to be amazed? All right, let's go a little bit bigger. Why don't we do iron? It's right there. Iron, 26. So it has let's see. Yeah, 26 protons. So this is iron, Fe. It has an atomic mass of 55.85. So round that up to 56. 56 minus 26 is 30 neutrons. All right, let's figure this out. Yeah. Iron is in the fourth row. So 4 rings. Like we said, the first row can only hold 2. We already counted that out in the last one. The next row can hold 8. We counted that out when we did aluminum also. The third row can also hold 8. We have 1, 2, 3, 4, 5, 6, 7, 8. And iron is 1, 2, 3, 4, 5, 6, 7, 8. Oh, I just happened to do that. It's 8 in. Ta-da! All done. Now, as you saw, it's not like iron is all the way at the end. That is krypton. Now, if we were doing krypton, I'm going to change this. So krypton is 36. Let's see, 85 minus 50, so 49 neutrons. And if we were to count all the way to the end, we would have 18. If you're wondering, but Miss Komar, how do you know? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So that, and it's all the way at the end. It's one of the noble gases. So that's 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. It's all the way at the end. It's one of the noble gases. So since this entire outer ring is filled, this is actually why the noble gases don't react all that much. Why other elements are a lot more reactive and why noble gases are generally non-reactive. Because as we were talking about with the bonding video and ionic and covalent bonding, atoms are most stable when they have a full outer ring. Generally, when they bond, is to either get electrons to fill that outer energy level or orbital, or to share electrons to fill that outer orbital. Now, since krypton is all the way at the end, it has a full outer shell, which means that it doesn't need to steal any electrons or gain or lose electrons or share electrons in order to get a full outer shell. And that's why the noble gases tend to be more stable, because they're already set. All right, let's do one more. Let's do a hard one. All right, let's see. How about we do oganesson? I am not sure if I'm pronouncing that correctly. It's one of the newest ones. It's right here. It's 118. So it has, in the nucleus, has 118 protons. Its atomic mass is 294. And I'm going to use a calculator just to make this go a little faster. 294 minus 118. And that's 176. So 176 neutrons. All right. Well, where is it? It is right down here, all the way at the end. So that is 1, 2, 3, 4, 5, 6, 7. 7 rings. So 7 energy levels. One, 2, 3, 4, 5, 6, 7. All right. Well, we already did some of these together. So the first one can only hold 2. 1, 2, then 8. Then 8 again. And then 18, because that's the one that had the row with iron and krypton. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Now the next one, row 5, can also hold 18. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. All right, how about the next one? So if you remember, we have these 2 spaces where these fit. So we're going to have to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And then same thing to get to here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And that, my dear kids, is how you draw a Bohr's model. All right, so I hope you found that educational. I hope it helps. But yeah, that's it. So you guys stay awesome, stay safe, and just be amazing, because I know you guys are. All right, you guys, take care.